Hi everyone, I'm going to show you guys how to integrate this MIT question. So we have e to the power cos x into cos 2x plus sin x in brackets. Right? So before going any further, you guys need to know that e to the power, let me just change the color, e to the power I theta equals to cos theta plus I sin theta. So if you look at the question, if you focus on this, how do we write this in terms of e to the power I theta? Now this comes under complex numbers. If you guys don't know about these, please drop a comment. I'll help you guys out. I'll give you guys a tutorial on that lesson. So how could you write cos 2x plus sin x in terms of e to the power I theta? So if e to the power I theta equals to cos theta plus I sin theta, you could write cos 2x plus sin x as e to the power I 2x plus sin x. Now that would be cos 2x plus sin x plus I sin 2x plus sin x. Now the reason we don't write this part is that this section is imaginary, right? So I represents imaginary values. So you don't have to consider this part when you integrate your question. All you have to worry about is the real numbers. Okay, this part is real, this part is imaginary, right? So you don't have to worry about this. Now when you go back to your question, you can put this in and you can go on further. All right, the reason the question doesn't have this part is because it's imaginary and it's not real. All right, so if you guys have any doubts with that, please drop a comment. All right, so we could write e to the power cos x into e to the power I into 2x plus sin x dot dx. Now when you do these questions, you usually have to write r in front, representing that you always take the real numbers into your integrals. So now both bases are e, right? Now we can bring them together. So you can see, now let's do this. Let's expand the brackets. So e to the power cos x into e to the power 2xi into e to the power I sin x. Now we could bring this and this together, right? So you could write e to the power cos x plus I sin x into e to the power 2xi. Now what can you do? Now what does this represent? Now did you see, before I started the question, I wrote e to the power I theta equals to cos theta plus I sin theta, right? So instead of writing cos x plus I sin x, what could you write? You could write e to the power ix instead, right? Because e to the power ix equals to cos x plus I sin x. So now you could write e to the power e to the power ix into e to the power 2xi dot dx. Okay, now what do? Now let's do something like this. Now let's break e to the power 2xi into e to the power xi into e to the power xi into e to the power xi dot dx. If you guys have any doubts, please drop a comment. All right, now before going any further, I want to show you guys something. Well, to do this integral, you need to do integration by parts, but before going into that, I want to show you guys something. Now let's differentiate e to the power xi. Now what does this give you? Now how do you differentiate e to the power terms? So first you differentiate of what you have at the power. So how do you differentiate e to the power xi? So I is basically, you could consider that as a number. You don't have to worry about that. It's not a letter, it's a number. You could take it as a number because I equals to root -1, right? So the differentiation of this, so I comes down, and this would be the differentiation. Now if I'm differentiating e to the power xi, this would be I e to the power xi, right? So then this would be I e to the power xi into e to the power xi, right? Because when it comes to e to the power terms, it's always the power that you have to differentiate, right? So it's basically like the same thing, but here the case is we have a different power, right, which is e to the power xi. So you have to differentiate that, and that comes down. So if you guys have any doubts, I'm repeating again, so please drop a comment. I'll help you guys out. All right, so now we have this. Now let's go back into our integral. E to the power xi into e to the power xi into e to the power xi. Just bring these two together. Now let's do integration by parts. We'll take one term as u and the other term as dv over dx. Now this term, we'll take it as u, and this term, let's take it as dv over dx. You know why I'm taking this as dv over dx? Can you see that there's a similarity between these two? So we can easily integrate this, right? That's why I'm taking it as dv over dx, because now we have this right there. So we have nothing to worry about. So u equals to e to the power xi, and dv over dx equals to e to the power xi into e to the power xi. So du over dx equals to I e to the power xi, right? Just take I as a number. Take it as a numerical number, so you don't have to worry about it's nothing confusing. All right, just imagine as if, for example, e to the power 2x, when you differentiate e to the power 2x, 2 comes down, right? It's just like that. You have to differentiate the power. So what's the integration of this now? Now if you integrate I e to the power xi into e to the power xi, you get e to the power xi, right? So now what we need is this. So we have to get rid of this I. So what do? So we divide both sides by I. Basically we multiply both sides by 1 over I, right? So then if dv over dx equals to this, v equals to, so your integral of that is 1 over I into e to the power xi. Now we found u and v. Now what's the formula for integration by parts? This is your formula. Now let's follow the formula. You can see we have u into v. So u into v is 1 over I into e to the power xi into I e to the power xi, right? Minus v 1 over I e to the power xi. Oh, I'm sorry, I think I made a mistake. Oh, this is v into u, right? So u is e to the power xi. I wrote du over dx by mistake. So now here we have v into du over dx is I e to the power xi dot dx. You can see the i's cancel off, so we have 1 over I e to the power xi e to the power xi minus the integral of e to the power xi e to the power xi. Now this was the same thing we had previously, right? Can you see? The same thing. There's no change at all. So now I don't have to do it again. Now you guys know that the integral of e to the power xi into e to the power xi is 1 over I e to the power xi. It's this. So this is your answer, but we need to further simplify this, alright? So e to the power xi plus c. Now what you can do is, let's take 1 over I outside, and we could also take e to the power xi out. We could take this term outside too. So it's 1 over I into e to the power xi into e to the power xi minus 1, right? Plus c. Now e to the power xi equals to cos x plus I sin x, right? Now instead of this we could write cos x plus I sin x, right? So 1 over I into e to the power now e to the power xi, now we could write cos x plus I sin x into e to the power xi, again cos x plus I sin x minus 1 plus c. But we are not done yet. So the thing is, we need to get rid of this I, okay, and this I. So what we can do is, let's write cos x and sin x in double angle formulas. So cos x equals to 1 minus 2 sine squared x over 2, right? And sin x equals to 2 sine x over 2 into cos x over 2, right? So let's write 1 over I e to the power cos x plus I sin x into, now instead of cos x I'm going to write 1 minus 2 sine squared x over 2. We have minus 1 over there, so you could write that instead, plus I into 2 sine x over 2 cos x over 2 plus c. Now you can cancel these off. Now do you guys know how to get rid of this I? So what you could do for that is, you could write e to the power cos x plus I sin x into I into 2 sin x over 2 cos x over 2 minus 2 sine squared x over 2 over I, because you can see this was multiplied with everything, so you could just write it like this. Now to get rid of that I, we need to multiply the numerator and denominator by I. Now since this is multiplication, we could just multiply I with these two terms inside the brackets. And now since I equals to root minus 1, I squared equals to minus 1, right? So now e to the power cos x plus I sin x into, Let's expand the brackets. Now we have I squared 2 sine x over 2 cos x over 2 minus 2I sine squared x over 2 over I squared. Now instead of I squared, I'm going to write minus 1. Minus 1. Now what can you do here? You can see all our terms are negative. We take minus 1 out. So if we take minus 1 out, this would be positive and this would be plus 2, right? And now you can cancel them off. Now we got rid of the negative sign. Now you could write e to the power cos x plus I sine x into 2 sine x over 2 cos x over 2, 2 here, okay, plus 2I sine squared x over 2. Now we have 2 is common too, so you could take that out instead of writing it inside the bracket. So we could write this, and now we could take sine x over 2 outside too, right? So we have 2 sine x over 2 e to the power cos x plus I sine x into cos x over 2 plus I sine x over 2 plus c. Now what can we write? So now previously I wrote e to the power ix equals to cos x plus I sine x, right? So if this is cos x over 2 and sine x over 2, this would be I x over 2, right? So now you could write 2 sine x over 2 e to the power cos x plus I sine x into e to the power I x over 2 plus c. Now here, let's break this down. So 2 sine x over 2 into e to the power cos x into e to the power I sine x into e to the power I x over 2 plus c. We can bring these two together, right? So you write 2 sine x over 2 e to the power cos x into e to the power I x over 2 plus sine x plus c. Now we are really close. Now when writing the final answer, I told you guys it's always the real values that we need to consider, the real terms. So what's this? So e to the power I x over 2 plus sine x. This is cos x over 2 plus sine x plus I sine x over 2 plus sine x. Now when writing a final answer, we don't consider this because that's imaginary. We only take the real terms. So now your final answer would be 2 sine x over 2 e to the power cos x, and instead of writing this, you write this guy over here. So it's cos x over 2 plus sine x plus c, and this right here is your final answer. It wasn't that bad, right? So that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.